What's up, guys? Welcome back to Vanover Machine and Repair, and we are continuing on with the horizontal boring mill series. Now in front of me we have two of the last remaining parts that need to get fixed, and then we can get this beast back together. Let me bring you in close and show you what we're going to be doing in today's video. Taking a closer look at these parts, you can see the main issue that plagues both of these guys is chipped teeth. Now these parts are a little bit difficult to make and extremely expensive from Lucas. One of these guys, Lucas has told me they are not even able to source it. That would be this part here, mainly because the etching on the numbers, basically they just do not have someone who can do that, and they have to send it out. And this part over here is extremely expensive to manufacture. I wasn't given an exact cost on this, but it could be upwards of $5,000 or $6,000, and this part here would be much, much more, and they wouldn't even quote it. So these parts are extraordinarily pricey. The main reason for that is that these are cast iron, and when they were manufactured, they were probably cast as a blank, and then they came in here and hobbed these teeth with a gear hob, and then on this part, they had to send it out to get it either powder coated or plated and then engraved, and then not to mention doing the machine work. So pretty interesting and difficult parts. Now fortunately we are going to be able to repair these parts for a fraction of the cost, and I think we're going to be very successful. Now the proper way to address this would be to replace both of these, but that's not even possible with one of these. And to be honest, I don't know that it's worth the effort of fully remaking these parts because they really don't do a whole lot on the mill. The main function of both of these in conjunction, this part lays on top of this, and there is an idler gear that goes inside of this sun gear, is to set the exterior and interior limit stops for the quill. So basically what happens is this has two notches here, and as it rotates around, it kicks a trip out and it stops the quill from overextending or underextending back into the headstock. And so all these gears do is create the correct ratio to spin this hand wheel slowly so that this hand wheel will do one revolution basically for the full travel of the quill. And it's for that reason that I think the way we're going to approach this repair is not only going to be cost effective, but I think it will work well for the application. So in terms of the method we're using to fix this, there are a lot of ways to go about this. All of them are unconventional other than replacing them, but the best way that I have come up with in terms of fixing this would be to take measurements, go in here and machine out both ring gears, leaving a lip on this one to save the text, and on this one we could machine it completely off, and basically get two new rings, laser cut, drill and tap both pieces, and install both rings. The benefit in doing that is a laser cut ring gear is going to be very cheap compared to getting a ring gear made, and I don't have the setup to make a ring gear like this, and it would be very time consuming, and I don't want to do that. So that was my first approach. We are going to still try and do that, but I have been kind of working back and forth with the laser cutter to see how possible that's going to be in terms of the precision of the teeth. They don't need to be crazy precise, but if they're too rough, they're not going to work. And so we do have a backup plan if we can't do that. So with that being said, let me show you. We went ahead and made a 3D model of what we're going to try to do. I'll show you that and how we're going to get this done. Here's a shot of the test prints we did, and this will give you kind of a good visual representation of what I'm trying to do here. We'll machine that area out, and we'll have a part like this, hopefully made out of the AR plate, and we'll go ahead and drop it down and bolt it all around. We have the counter bores set up there, so we can use 12 10-32 screws, and that should be more than strong enough to hold this in place. What I really like about this design compared to the factory unit is whether we're making them out of the laser cut parts or the plastic parts, if they fail or break, we can simply unscrew the part. It's about 5 minutes to disassemble it at this point, so it's very easy to access. and then we can take the failed part out, reinstall a new part, and we can be on our way very quickly, very cheaply, without having to scrap these expensive parts. So in terms of the laser cut parts, I just finished up talking with Send. We got the design finalized, and I'm going to be making them out of AR 500 plate. It sounds like they're fairly confident the tooth profile is going to be crisp enough to work for our application, but the jury is still out. I could have got them made out of mild steel, but I figured, hey, what the heck, let's just make them out of something a little bit harder, and it pretty much cuts the same anyway. So we're going to be going with the AR 500. If for some reason we get the plate and the teeth profile is just not precise enough, we will move to plan B, which is using the 3D printed rings. These rings won't be the final part. These are just kind of the prototypes. I want to make the parts out of nylon. So went ahead and ordered up that filament just in case we need to go down that route. But plan A is to roll with the AR 500 laser cut parts. Now those parts are going to come to us without the counter bores, and we are going to need to enlarge the holes just because of the wall thickness. So we'll kind of see how that goes once we get the parts, but that's the game plan for the ring gears. Now, the other issue that we have here is when we took this apart, we were actually missing the idler gear. So I went ahead and printed a test gear and tried to figure out the size of the gear because we don't have any technical drawings on dimensions. Now, luckily, I was passing through Spooner, Wisconsin. We took a stop by Josh Topper's shop, and we did pull his machine apart, which is almost identical, and I verified that this is the correct gear. So unfortunately, even though this is a 16 pitch gear and it is a 16 tooth, this is a very uncommon gear in this configuration. They have lots of gears online with hubs, but not a lot of gears with a width of this thickness. So we're not able to source this gear readily, and so what I'm going to do is I'm going to be printing this gear out of nylon, and I think it'll be perfect. So we should have AR 500 ring gears and then one nylon idler gear, and if the gear fails, these gears will cost about 5 cents to make, and it won't damage anything, but I think it will be more than strong enough for the application. So with that being said, we're going to start on this part over here. We'll get it measured out, and then we'll move over to the lathe so we can get this machined. We're going to come in here and touch off. That'll be our 0. We'll 0 the DRO, and then we'll measure how deep we're cutting from there. Well guys, we got greedy. It was working perfectly fine, but the wall got a little too thin. I thought I had plenty of room, but the reality is with the indentations for the text, I think I overheated this, and yeah, we broke this. So all that work trying to save the original numbers, and this part is not going to be factory. But you know what? At least I'm screwing up on my equipment and not on your equipment, right? So we're going to just go ahead and just machine this off. We're going to lose the numbers, but other than that, it'll make no difference. And to be honest, I don't really care that much. I don't think I'm going to be using these numbers. I talked to Josh, and he said he never uses those numbers. So I don't think it's going to be that big of a deal. We're still going to have the markings, so we'll still be able to see the integers, but we're just not going to have the call outs here. So a little unfortunate, but you know what? It is what it is. This is what happens when you're trying to repair parts that are impossible to source. Things happen, and you just got to adapt and overcome. All right, the next step is to drill our hole pattern for these 12 bolt holes. And this is how we're going to be doing it. We're going to be using the rotary table. Luckily, I have this set up from doing the clutch pieces, so I didn't have to put a lot of work into centering this up, but I'll show you what we do. So I use the coaxial indicator, turn it on, and you can see we're within maybe a thousandths. And that bore isn't perfectly clean, so I'm going to leave it where it's at, which is the location where the clutches were. And we'll go ahead and come in here and spot all 12 of these holes, drill them, chamfer them, and tap them for 1032. cast iron, self-lubricating, so I'm not gonna lubricate these. There you go. All right, we got these pieces machined and we are finally done almost with making parts and we're ready to reassemble. Before we jump into reassembling the boring mill, I want to just go through the parts that we fixed and made just for anyone who isn't watching along. We do have separate videos on each of them. I'm just going to really quick run through where we come and where we're going with each of the parts. So all the way over here on the side, we have this gear. This gear was destroyed from this guy basically being rotated too many times. So the hub base was destroyed. We made a new hub, pressed it on, and bolted it down. This gear is now in good shape. Lucas wanted 6780 to replace that gear, and we saved ourselves a bunch of money there. This clutch housing, same thing. These lobes were kind of worn. On the back, it was broken out there. We made a new part out of 4140, hardened it, did the whole process. We grinded it. We went crazy on this part. Everything is nice and tight. Everything is dimensionally accurate. We have a new one of those. I believe this was about 5 G's, and we made that for the cost of the materials. We had a 1/2-inch pin before in the original. It was wallered out. We switched to a 9/16" pin. The pin is obviously tighter in the new part. That allowed us to file down the shaft and basically make sure the fitment on the pin is tight, because the fitment on the 1/2-inch pin was kind of loose in the shaft. So we did that, and then we necked it down in the middle so we could still have room for our spring to kind of come together. So that's good. Clutches, these guys were $2,500 to $3,000 a piece. We made 2 new ones, 4140, hardened it, did the whole shebang. Tooth pattern is different, but it should work out great. The design is a little bit different, but it should be better. The handle, this handle was loose. These handles basically kind of like shook. So the pins were wallered out. We punched out the pins. We drove in some new ones, drilled it out. These handles are nice and tight. This interface on the back, this tri-lobe, was also worn. Off camera, didn't show you guys that. It's real easy. When we made this, I made a second, basically male piece. So we took the old one, chucked it up in the lathe, bored it out, pressed, shrunk the new one in. So it's like a 2/1000 interference fit. So we warmed the outside, we shrunk the center, pressed them together, and then when that cooled back off, this is a nice fit. The reason we do that is because if this wears, we can go ahead and push this out and replace this part. It'll be much easier. We made this like 30 Rockwell C, and this is 4140 that's not hardened, it's annealed. So this will wear first, it'll be easier to change, but probably it'll never wear out in my lifetime. So we got that fixed. Over here, this is the parts that we've been working on in the video. So we had some damaged gear teeth. We wanted to originally use AR 500 plate, laser cut. A lot of back and forth. Finally figured out that the laser cut parts weren't going to work, namely due to the ratio. So the thickness I need here is 400 thousandths in this dimension. 3/8 is the closest size, but it's too small. So I would need to step up to 1/2 inch and machine it down, no problem. But piercing a 1/2 inch plate would basically mean that these holes would be too small and too thin to the edge, and these teeth are too thin. They could do it in 3/8 plate, but I'd be 30 thousandths undersized before machining, and 30 thousandths plus 30 thousandths would mean these handles would be 60 thousandths together. So we opted for 3D printing. Now let's talk about that in more detail, because that is what this video has been about. So we ended up printing these out of ABS GF, real nice surface finish, really strong, looks great. I printed a bunch of examples and tested them out because 3D printed material can shrink. So we got the exact dimensions, which is important because the gear is going to be interfacing this. So we got these. Now, this material is not ideal in that because of the fiber. Over time, that fiber can kind of eat the gears. The same thing that adds some structure also adds some abrasion to the material. So these will work for the assembly right now, but I actually ordered some some nylon, 100% nylon, and we're going to be making these parts out of nylon. So I have the nylon basically warming up to dry it. We'll get those printed and swapped later. These parts are super easy to swap. But I actually think that these 3D printed parts are going to be a better fit. They allow me to get the exact dimensions I want. If for any reason my gear profile is off and the mesh isn't perfect, all I got to do is go into the slicer, increase the percentage, which basically makes the gear larger, and we can dial in the perfect amount of backlash really easy in a way that we couldn't do if we just committed to a laser cut part. So I think that's going to work out great. And this really isn't under much load, and it'll hold up great. The other benefit of using the nylon is these parts come together, so they'll be very low friction. Nylon is great for gears and is perfect for this. So we got this part done as well. Off camera, I went ahead and just machined the outside, and I just kind of clean it up. We also have a new clutch. I paid $500, $600 to get that rewound. I think I messed it up when I pulled it out. I pulled the wires out, or it was hanging on. So we got a brand new high-speed clutch. The very last thing we have to do is address this handle that's been welded, cracked, re-welded, and is warped and is bashed up. We may throw the info or the footage of me doing that in this video, but I am 3D printing an entire new hand wheel. I modified the shaft to add 2 keyways instead of a press fit, and there's not a lot of force on this because it's for fine feed, so I think it'll be perfect for 3D printing. I actually made the handle a little bit bigger for more leverage. We added some nice Lucas precision text to it and some really nice knurling to the back. So I'm kind of waiting on some filament for that, so we'll see how that goes. But with that said, we have everything that we need to get this thing reassembled. I could put the handle on later, so let's go over to the mill and start getting this stuff finally reassembled. All right, we got a custom-made spacer here, and then a modified spacer. We were missing some parts, so we had to improvise. Really fat snap ring. And in case anyone's wondering, I've already had this apart and together multiple times. That's pretty typical. A lot of times you don't realize that in the video, but this is probably the 4th time I'm putting it together. And that's pretty typical for me. I learn as I go, make mistakes, make corrections. So, just letting you know how it really goes. Like for example, we needed to make these spacers and modify them and take them out and reinstall them. So that way there was no in play. Had this plate off multiple times. So it just what it is. Hopefully from here on out, should be relatively smooth. I had some issues getting this top shaft in with the bearing. But hopefully from here on out, we should be kind of smooth sailing. So we got that snap ring in. We're going to go over to the bench and assemble our clutch housing and kind of go from there. Just real quick, I know someone will appreciate this. This is that shaft that I was fighting. So people ask all the time why I don't use brass hammers. I do have a brass hammer. I do use it. But in this case, there is a snap ring here. This gear is on a spline shaft, and in the back, which you can't see, there is a, what do they call that? It's like a castle nut, I believe it is. Has different notches in it, and then there's like a retaining pin. So when I was getting this out, you have to tap on it, and I was using a brass hammer, and in doing so, it actually mushroomed this gear. Even though it's brass, even though it doesn't make sense, it does that occasionally, especially if the material is thin, and because there's a snap ring cut in there, there's a really thin area of spline, and it deformed. So when I got this all apart, I didn't think anything of it. You have to put it together in a certain way, and the last thing you do is put this gear on, and I was fighting to get this gear on. So I had to disassemble it, pull the gear off, take the faceplate off, just so I could file down the flats that mushroomed from tapping on it with a brass hammer. Got it all back together, and then I couldn't get the screw on the back. And why? Same issue. I was trying to fight it. I actually made a special socket because that castle nut has like 4 notches in it. It's installed, or I would show it to you. Tried to use this to get the thread started, couldn't do it. Took it apart again, took it over to the lathe, used the lathe to clean up the threads, test fit the nut, everything was golden, reassembled it. My point here is that more so to me and to anyone else who's doing this stuff, machine tools are a very particular fit. And sometimes you do got to hammer on things to remove them. That's just the nature of the beast. And even if you don't think you're damaging things or you don't see it, one thing I need to do, and maybe some other of you guys need to know this as well, before you reassemble it, just test fit the nuts, the gears, make sure everything works, because it's a lot easier to address it when it's out than taking everything back apart just to file a shaft down so a gear can slide on. And this happens to me all the time because I just forget to do it. So that's the reality of how this stuff goes. We got that nut on that compresses the bearings. We got this on. Everything's happy and nice and good. But I just thought I'd share with you a little bit about the issue that we had. All right, let's actually go over to the bench and get that clutch assembled. We got our outer clutch that drops on here. These holes are clearance to install the screws on this. And then we have our other dog clutch. And the manual, or the TSB, Technical Service Bulletin, for issues on this machine state that these pins can be sheared off. If you see in the old part here, I don't know how much of that is seeable, but what happened is this originally had, I think it was 4 screws and a couple dowel pins holding it, and then as it sheared, they would rotate and then keep doing that, and so that's why you have a ton of holes right here. Well, anyway, when these screws fall apart, they fall into the gearbox and create a lot of damage, which we're repairing. So on that technical service bulletin, it tells you to use RTV on these screws, so that way at least if they shear, they're going to stay in place and it helps them from walking out. So we're going to be doing that. That's pretty atypical, but I figured I'd answer that ahead of time. All right, so we have some RTV over here. And it may not be obvious, I think we already talked about this, but I added more screw holes and eliminated the roll pins. We have brand new screws. And I'll torque these down, not because it matters, I just want to get them consistent. All right, we're going with 100 inch-pounds. There's no spec. I'm making it up based on what feels right. There's really no reason to do this other than I want these just to be consistent because I know that they have a likelihood of backing out. We have a very mild press fit on this pin. Just using the arbor press. And that's a nice fit there. Get our keyway in there. Make sure we're nice and clean. It's a nice fit, you can feel that. And then we need to line up our gear here. There we go. We're going to come in here using some Loctite and put these screws on. Okay, 2 left. That top one felt a little off. Last one. All right, we got our nylon ring gear here and our custom modified screws. So let's go ahead and get this ring gear installed. Got our nylon ring gear here. Just a gentle tap, tap, tap it in. And our tiny little snap ring here. My snap ring pliers are too big for these holes. Oh, there she is. You know what? I need to make an 1/8 inch spacer for that. All right, here's our custom washer. All right, we got the Turnslide back together and I think we're good. Everything seems to work properly. I do need to make some adjustments to this handle to tighten it up a little bit, but we're not going to do that yet. The reason for that is I want to get this back together and making sure that it's going to work. When we took it apart, we were missing so many parts that I don't even know what it's like when it's working. So I want to get the machine running, everything is installed, and then once it's running, we can mess with it and we can basically tweak it from there. So we got the top cover back on, we got our new gauge in there, and I went ahead and removed some of the old DRO type stuff, the old school stuff, and I removed a bunch of wiring that went to that. So since I fired this up, which has been about 3 months at this point, that's what we've done. We've done a ton of work. So this will be the first sort of fire up. I do need to reinstall the clutch, which you can see sitting on the top. And the way that clutch is designed, basically you need to energize it so all the plates come together, and then you can basically put it on the splines of the actual gear so all the clutch plates don't fall down. But in order to energize that, we need to power on the machine, and I don't want to power on the machine dry because this pump is probably going to kick on. So we're basically going to fill the machine full of hydraulic oil, and this will be the first fire up, and the main purpose is to install that clutch. Once we get that clutch installed, then we'll come back and take a look at this and basically make sure if we need to make any adjustments or do any tweaking, we can do it from that point. Like I've mentioned before, we've had all these parts apart and back together 4 and 5 times. There's no way around that. Me making mistakes and also just not having all the information, being an older piece of equipment, and us having missing parts. And so if this fires up on the first go, great, but I'm sort of expecting problems, as has been the theme. So we'll fill it full of fluid, we'll see what happens, and eventually we will get to where we need to be. So with that being said, I thought I'd show you guys the first fill up. We have brand new oil sight, and of course everything is clean on the inside. All the oil lines are flushed, new Bijor fittings. We have a video on that, but everything oiling should be pretty much spot on. So this will be the first time testing that as well as a new motor in there for the oil pump. So with all that being said, let's get this bad boy filled up and go from there. I'm giving you guys a shot at the oil sight because this is the virgin filling. It's never been filled before. It's a dry area, and I'm using 5 gallons of, I think it's number 40, number 32 hydraulic oil. I've already talked to the manufacturer. There probably was a more specific oil, but this should work fine. Oh, there she is. Thought I would have taken more oil than that, but it is what it is. I'm actually going to overfill it a little bit because I'm thinking that once the pump goes, it'll probably lose some. We can always drain some out. All right, let's see what we got here. So I don't remember how to turn this on. I'm going to be real. Okay, that wasn't too hard. I don't know if this oil is spindle only. I'm not sure. All right, couple of things. We got no pressure here. That could be, let me put it in. All right, let that. Spindle's turning now. No pressure yet. Our pump is running, I can hear it. So I don't love that, I'm gonna be honest. We may need to prime this. Honestly, this machine seems a little quieter than I remember. Let me turn this off. Okay, our clutch is kicking on there, so that's good. Okay, so what I'm gonna do, I think we're building pressure. Oh, this is exciting, this is exciting. It took a minute. This gauge has a lot of travel. I think if I remember right, on someone else's machine, it was only running like 8 or 10 PSI, so I see it moving. All right, we know the clutch is working. So what I need to do is I need to kick it on like that so I can install it and then kind of go from there. I'm gonna do that off camera. We'll see if the pressure builds. There is some pressure, which is good, but I would have definitely liked to see more. I may need to prime this pump. So let me work with that and I'll bring you back. Well, it's been quite some time since we worked on this last, and it looks like we lost some of the footage in finishing out this video. So I'd figure I'd jump in from the future and kind of update you on what the last shot was about and give you some of the good and the bad of what you guys can look forward to with this build. So first and foremost, I know we were talking about oil flow. Oil flow is very important. That's why I did this whole thing on the head to get it cleaned out. We have about 30 PSI, which is about 10 PSI over stock. So the oil flow in the head is good. It took a lot of monkeying around in there to get that working. I'm gonna spare you the details, but good news, our oil is now working, it's clean, it's pumping, and it's consistent. So that's good. In regards to this area, we got all this stuff back together. For the most part, everything seems to be working fine. There actually is supposed to be some play here, and then when you disengage the clutch by running this nut down, the play increases. That's normal. At the time of doing this, or in the past, I didn't know that, but looking at other people's machines and doing some research, that's kind of how this is designed. In terms of the first startup and getting the clutch installed, all that went fine retrospectively. We got it in. The machine started up fine. Ultimately, this machine has a lot of issues. And I know we kind of have touched on that throughout this process, but this has been probably about 3 months from today, from the last scene that you shot. And what I've done since then, which I won't go into too much detail because there will be individual videos, but we've ripped out both of these gearboxes, rebuilt them. I've rebuilt the motor, and we've started redoing the electrical, removed the table on the saddle, and this machine is in really bad shape. But this machine is a fighter, but we don't give up around here, and we are winning. It just takes a lot longer than I expected. So you guys have a lot of cool content to look forward to if you like this machine. I hope you guys enjoyed the video specifically on wrapping up the issues here, and look forward to a lot more issues in all the other areas on this machine. And if you're astute, you can probably tell that a lot of stuff has been switched and changed. I think a big theme of this machine that may not be obvious, and certainly wasn't obvious to me when I started 6 months ago, is all of the electrical gremlins and issues and limit switches on this machine. The machine is actually not that hard to run, but there are so many limit switches that prevent the motor from kicking on and off and prevent you from feeding. And so a lot of time when I was like fumbling around not knowing what was going on, it's because finicky switches, broken stuff that I have slowly been sorting out. So my comfortability with this machine has increased tenfold, and we're going to be doing a lot of great work with it. We're going to be getting this thing fully fixed up mechanically, and it's going to run great. And it's already running amazing and way better than it was 3 months ago when I was just messing up here in the head. So with that all being said, I hope you guys are enjoying the videos. I have been slammed busy in the shop with customer jobs, and that's great. But I've just been doing whatever I can to get these videos out for you guys, and there will be loads more content to come on this boring mill. So let me know what you think down below, and we'll see you in the next one.